to Josh Does Math. In this video, we're going to be calculating the derivative of 1 over x to the third. But we're not going to be using the power rule for derivatives. Instead, we're going to be using the definition of a derivative. So we're going to be using this equation. F prime of x is equal to the limit as h goes to 0 on f of x plus h minus f of x all over h. Now, for this particular problem, if you did use the power rule for derivatives, it would be extremely easy. But let's say that you don't know how to use that yet, or let's say you just want to take the scenic route instead of taking the superhighway. So we're going to be using the limit here instead of taking the shortcut. So in order to use this, we need to have f of x, and we need to have f of x plus h. Okay, so as h goes to 0. Now, f of x is really easy to find because we're given it. It's 1 over x to the third. What about f of x plus h? Well, it's just 1 over x plus h to the third. Just plug in x plus h. And this is all over h. So, as you can see, if we were to plug in 0 for h and try to solve the limit that way, we're going to end up getting 0 over 0, which you can't have. That's an indeterminate form. Doesn't tell you anything about what the limit really evaluates to. So the fact that we have a fraction within a fraction is a good indication that in order to remedy this indeterminate form, we're going to want to find some common denominator within our fractions up here. And an easy common denominator is going to be x to the third times x plus h to the third. It's just the product of the two different denominators. Okay, so let's get each of those in terms of that common denominator. So this will become the limit as h goes to 0 of, I'm going to multiply by x to the third on the top and bottom of this one. And for the second one, I'm going to multiply by x plus h to the third in the numerator and denominator. So, and that's all over h. So now you can see how these have a common denominator. And we can also just move this denominator to the very bottom of the fraction here. And we should do that just to make it look even simpler. And there we go. If you plug in 0 for h right here, and try to solve the limit again that way, you're going to find out that you still get 0 over 0. In other words, you haven't done enough work yet to get a different answer than this indeterminate form. So how do you perform enough work to get out of this indeterminate form? Well, I'm just seeing this up here. This is something to the third power. Maybe if I actually compute this instead of having it in this form with a power, if I use FOIL multiple times, maybe some stuff will cancel, especially with this and with the h down here, and maybe it'll cancel. So I'll try that as my next step. So we got x to the third. So here's what I'm going to do. I'll write out x plus h. So that's one of the three factors. With the other two factors, I'm just going to do FOIL on them. And that's what I get. And now I'm going to distribute this term to each of the three terms within the limit. So this is going to become x to the third minus And this is all going to be inside parentheses, and then I'll distribute the negative as a step after this. So this is going to become x times x squared, so that's x to the third, h x squared, so it's x squared h, x times 2xh, so that's 2x squared h times this mess, that's going to be 2x h squared, and finally the last term. And that's all still inside parentheses, and it's all over this in the denominator. Okay, now what's my next step? Well, I'll distribute that negative, cancel some stuff out, and hopefully we don't get 0 over 0 anymore. Okay, so this is going to be x to the third minus x to the third minus x squared h minus 2x squared h minus 2x h squared minus x h squared minus h to the third. And we still have the same denominator down here. But as you can see in the numerator, we've got some stuff that cancels. X to the third minus x to the third. Bye-bye. These two terms right here, they're not going to cancel, but we can combine them. So I'll write that down in a different step here. Let's combine some of these terms to make it a little easier to look at. So minus something, minus 2 of something, that should give us minus 3 of something. Same thing with this, negative 2 and negative, should give us minus 3 of whatever this is. Okay, and then we just have this h to the third on the end. Okay, if I were to plug in 0 for h here, I'm still going to get 0 over 0, which is wrong because it's an indeterminate form. So how do I get out of that? This is the step that actually lets you get out of that pickle. So you can see that there's an h in the denominator and an h in each term in the numerator. So why don't we divide by that factor of h in the numerator and denominator that's causing all of the problems. Negative 3 x squared minus 3x h minus h squared. And we've got the same denominator except for there's no h anymore. So this is what we got it down to. Okay, well, how about we try to plug in 0 for h now? See what happens. We get negative 3x squared. This term becomes 0. This term becomes 0. Okay, that's easy. How about the denominator? Well, we've got a factor of x to the third, and if you put 0 in right here, this thing also becomes x to the third. So you just use the exponent rules right here. You can see that in the denominator, these exponents end up getting added. So that becomes x to the 6th power. And we also use the exponent rules right here to show that these two exponents get subtracted. So you end up with negative 3 over x to the 4th. And that's as simplified as it gets. So that's equal to f prime of x, the derivative of f with respect to x. And there we go. That's that problem done. Thanks for watching.